So to start with, I'll explain that there is going to be a lot of content throughout this notebook, but thankfully you guys can get hold of it at the end to have a look into all the stuff I miss. So this is just a quick table of contents of what we're going to go through. As you can see, we're going to start with going through a workflow using Wolfram Alpha Pro, Mathematica, and the online version. They will then go through teaching and research applications of the Wolfram language. So to start with, I just wish to introduce Wolfram Alpha, which is something I would hope you guys have heard of before, which is actually one of the powering pieces of technology behind Siri. If you happen to ask Siri a mathematical-based question, such as the one shown on the screen now, it will in fact head over to Wolfram Alpha to find out the information for you. Wolfram Alpha is our computational knowledge engine, which you can find as a website version just by typing in on your favorite browser, Wolfram Alpha. You'll be able to ask it a series of mathematical questions, like the time it would take for you to get from New York to Oxford, and it will actually sit there and do all the calculations for you, including, in this case, traffic. Here is a quick visualization of that website. As you can see, it can in fact be used for a variety of mathematical applications. I used it for one during my dissertation to assist me with complex mathematical problems such as a variety of differential and integral equations. Not only does it provide you with a solution, but it also provides you with a step-by-step process as well. The same system can actually be accessed directly through the Wolfram language using either Mathematica or our various cloud development platforms, just by using your the equals sign on your keyboard. So click into an empty cell like so, and then just press equals, and you'll see it comes up with a lovely field with which you can put in your question, and it will answer just the same as it would on the web browser-based version. There are a series of tools within the Mathematica and the cloud versions that you will find particularly useful. My favorite has got to be the suggestions bar. If you happen to be typing in a question, so in this case, I'll just evaluate the one on screen, you'll see that it should come up with a suggestions bar of things to do next. Unfortunately, due to the fact that I'm in presentation mode, that's not going to happen today. Normally, there'll be a lovely bar at the bottom which will suggest a load of things that you may wish to try next, such as in this case, a visualization of the equation in question. When it comes to the Wolfram language, there's 3 simple rules to remember. All functions that we've put into Mathematica are in fact capitalized, such as the plot function shown below. You can see that we surround function arguments using square brackets, and then curly brackets in fact denote lists and ranges and other data structures. There is in fact a series of other useful tools, which I'm not going to go to in too much detail, such as the input assistant, which is very similar to the autocorrect on your phone. So for example, if I start typing in plot, as you can see, it comes up with a series of suggestions of things I may be attempting to do. I can click on any of these and it will give me a template with which to fill out, which is very useful and always the correct format and use for that function. There is also a series of palettes, which as you can see on my screen by clicking on this menu here, they're intended as a series of useful tools that allow you to do programming and visual aids very easily. My favorite thing has got to be the documentation center, which has a list of every single function we have in there, and it's split up into various domains of things you may be wishing to try, such as image processing and stuff, and image processing, sound analysis, graph theory, etc. And it will tell you everything from use of the function to templates to guides and tutorials on what they would expect these things to be used for. We have an online platform, which amusingly enough we've called Mathematica Online. The system itself is pretty much exactly the same as the Mathematica I'm using here, but it's available through a browser, which, as we've noticed, is very useful for tablets and phones and allows you to develop on the move. Or if you don't happen to have a PC, then being able to develop on the device that everybody seems to have, which is a mobile phone, is quite a powerful tool. As it shows, there's no installation required. You just open it in your browser by typing in www.wolframcloud.com. As I've attempted to point out, the language is exactly the same. The palettes, the auto-completion, and the suggestions bar, shown in the bottom of this image, is all exactly the same, including all the visualizations. There is no difference other than the fact that it happens to be in a browser and doesn't require an install. So now on to teaching applications. So we have a series of functions such as manipulate, which we believe are a really particularly useful tool when it comes to presenting a variety of concepts to others. So in this case, I can quite happily plot a sine function using a very simple piece of coding. That's a nice and interesting visualization, but rather static. The great thing about this, though, is that I can then put this into a very simple function known as a manipulate, very simply as so. So in fact, we'll start that as a 1, because otherwise you won't see it very well, and then change that to a 10. So just a bit of live coding for you there, and what it results in is an interactive manipulate, which you can then use to change to show the variation of something live in front of people like I'm doing now. A nice and simple but powerful tool. This works with a large variety of functions, several of which I can not necessarily go into, but here's just an expansion of a simple series of brackets. The great thing is I can put this into a manipulate, and it will go on and on and on as long as I put that in the parameter. So as you can see, it's not necessarily just graphs and things like that. The great thing about these is these can go into as complex or as simple as you like. So as you can see here, I can affect the frequency, the amplitude, shift in a variety of different methods, and can even change the function. So these can go as really as simple as complicated as you like based on what you're intending to do. There is a little fun thing here to play around with when you get hold of the notebook. If you just place an image within there, you can sit there and play around and blur the image in and out as you so choose. Just drag and drop your image from your favorite website. Again, this manipulate system can be used again on the Mathematica Online platform because it's exactly the same both on desktop and online. Another useful feature is our extensive library of pre-built materials. We have the Wolfram Demonstrations project, which is a ridiculously large series of demonstrations that go through the large variety of topics we have available in our programming language. So there's some image processing ones, there's some system modeling, etc., etc. So another particularly good use is after you've produced all your interesting materials, whatever they may happen to be, you can then very easily share these in a incredibly simple manner. So I'm just going to re-import our logo directly from our website. This was the little tool that I showed you the code for earlier. I've just put the Wolfram logo in it, so I can sit there and blur that in and out quite nice and easily. The great thing is, using this very simple coding here, I can live in front of you now deploy that in a CDF manner, in which it will return to me a URL, which I can click on. And if you particularly want to take a screenshot of that and put that into your browser, you'd find that you're able to access that right now and play around with it appropriately. Because the permissions are set to public. That took all of 2 seconds. These things can go into a more complicated manner. This here is the code required to embed that same little application into a website or a course management system, for example. This system can actually be used to produce coding for a variety of different programming languages depending on what you're intending to use your stuff for. I've mentioned the Wolfram Alpha integration previously. What this actually means is we have a large amount of real-world data which you can actually pull into your Wolfram language coding and use that within your applications. So in this case, I can look up the melting point of caffeine, a very simple piece of information, which unfortunately doesn't seem to be working perfectly at the moment. But as you can see, it's produced me the melting point of caffeine. That's actually a symbolic object, which I can then use to progress and use within my calculations nice and easily. If I'm looking for something a bit more complicated, I can actually look up the chemical structure of caffeine. And as you can see, it's done that for me. I can do a series of image analysis or structural analysis on this, because again, it's a symbolic object. It can be used within my computations really simply and easily. One of the things that I'm keen to express here is the fact that we have a large amount of data on a large variety of subjects. So this is just the amount of data we have purely on just chemicals. We have over 44,000 records. So you've done that live in front of you just to make sure that you were aware of it. Here is a series of 10 items that you can find within that chemical data, just as an example. And each of those has a long list of properties, over half of which I do not understand. But if you're a chemist, I can imagine they're incredibly useful for you. As I said, it is on a variety of topics. We're not limited to just chemistry. Just as an amusement piece, a bit of an amusement piece, we have the molecular plot of caffeine as well, just to show that we do three-dimensional objects, of which you can sit and play around with and rotate. So they're not simple and static. There is just a quick link there to use of the Wolfram language in a chemistry classroom and its live application, just in case you're interested particularly in that one. So again, simple code to pull out this large bits of information from this large data repository. In this case, we're pulling out the literacy fraction of Zimbabwe, just one of the tiny pieces of information we have on such a country. But the great thing is you can actually plot this across this same piece of information across the entirety of Africa, and then display it in an interesting bar chart like so. So nice and easy, nothing particularly complicated. In fact, that coding is incredibly easy to read as well. If you then want to continue to make this interactive, again, nice and simple. Here you can see this turned into an application. So same thing, country data of a continent, literacy fraction, and then a series of continents you wish to choose from. So let's change it over to Europe. So again, you can see the literacy rate across that continent. We're not limited to just simple geographical data. We can also use weather data. So here we currently have the temperature in the State College. This can then be converted into Fahrenheit, because I'm aware that the Americans struggle with a centigrade system. But the great thing is you can then, again, very easily plot such data across a time line. So here it's just a simple dateless plot of the weather data. In this case, particularly pressure on the 5th in 2016. This can then be overlaid with a series of other data, so you can do direct comparisons quite nice and easily. Again, the coding is fairly simple, so much so that I'm happy to show you it. Geographical data is also included. So here we have a map of Champaign, which is the location of our office in America. But such geographical data can be used along with actual population data, and you can then graph the population data directly over the map. So in this case, we are showing you the population by region in China. Nice and simple. Key thing I'm then key to express now is the fact that I've gone through and shown you how you can use our data that we've put into the Wolfram Alpha knowledge database. You can quite easily work with your own data wherever it happens to be. The most common tends to be Excel spreadsheets or a series of databases. We happily support pretty much all of it. The great thing is that it doesn't matter where your data is. We support a ridiculously large amount of formats. Here is a series of examples based on some expected ideas. Here is the actual list of all the formats. In fact, that's out of date, bear with me. Here is a list of all the data formats we actually support currently. They have a variety of uses. This list actually extends annually or whenever we do a new Wolfram language update. So we believe that you should be able to find a format which is useful to you and is quite helpful. What you'll find is there is actually 189 different formats that we currently support. As I said, this increases with every new release. We also have the Wolfram Data Drop, which is our data storage for the Wolfram Cloud, also accessible via desktop. So here I'm creating my own little repository for a series of data. I can then retrieve that data directly from the actual repository itself and then plot it again in 3 very simple lines of coding, nothing too complicated. This can also be done with images. So here's an image of a lovely dog, which I also stored in that data bin. The great thing is that I don't even have to swap between data bins for the different types of data. I can store images and numbers all within the same location. Just be careful how it's used. I can then switch to doing some image processing, so I can find the outline of said dog quite nice and easily. But the great thing is I can then turn stuff into something more interesting for you guys to see, such as a manipulate, where I can change the variable of how many edges I wish to detect. This stuff can then be cloud deployed as a form page quite nice and quickly. So this is actually the deployment of a form page, which takes an XLS document and will automatically plot it for you. So it doesn't matter what the data is in there, the system will automatically interpret that document and attempt to plot it in a very interesting and sensible manner. Information can also be imported directly from a URL. In this case, this happens to be a URL link into a particular file. It could be a URL link into an API or an entire website. And then you can pull in, you can then go down into a granular level and pick out the information you actually want from your import. So all of this has been leading up to the idea of running a class with the Mathematica Online system. So you'd create your data bin. This is setting up a form page. To be honest with you, this is the actual construction of the form page. That's letting it know how to store the information. And as you can see, some appearance rules to make sure it displays in a nice manner. Then cloud deploy that form so that you guys can access it publicly. Normally, if I had more time, I'd go through and allow you guys to actually fill out that form, but I unfortunately don't have that time today. The great thing is, because as you can see, that URL is quite long and doesn't necessarily make much sense, we have a function known as URL shorten, where you put in the URL that we've created, put in what you wish it to be called, and as you can see here, we end up with a shortened version, which is a much easier to type in at speed. Normally, I'd then go through and show the information that people have already submitted, but again, not enough time here. So here is a quick demonstration of how comprehensive the language is. This is actually a graph of the number of algorithms and functions we put into the Wolfram language, populated by the flags for the various different Mathematica releases. As you can see, it's risen at quite a ridiculous rate over the past few years, and will continue to do so for as long as I'm aware of. All of this is led by our symbolic computation, which is evidently shown by our step-by-step solutions in the Wolfram Alpha Pro. But otherwise, as you can see, the symbolic nature can be used quite nicely to do some very interesting and complicated mathematics. So here is just a simple integral of a equation with reference to x. As you can see, it's in a format which you guys can quite happily understand. The full form of this is also available, but this is a shorthand version. You can actually type this in quite nice and easy using the palettes, which is how I did it myself, with which it gives you the type setting to actually do this in a nice and interesting manner. Again, you can do the same with a variety of different equations, etc. You can then use a series of multi-step problems and display those as just as easily and manipulate as was shown previous. Our symbolic computations makes working with numerics incredibly easy. I don't know about you guys, but A plus B is quite nice, is all well and good, but I would prefer to actually put a object or a numeric in there. And Mathematica does pretty much exactly the same thing. It will store a variable or value in that variable, whether you call it X, Y, Z, or just because, and then it will happily insert that as appropriate. A more interesting effect of this symbolic calculation system is the unit computations. So here I've added a series of 3 different units together, and as you can see, it's actually returned me a sensible system. This can quite easily be done using the equals shown earlier. So click into your cell, push equals, type in your unit, so 2.3 pounds. So that'd have to be British pounds in this case. He says British pounds. I missed the U as well. But the great thing is I could actually evaluate this and it would return me a entity which would represent 2.3 British pounds, which actually comes to be £2.33 pence. The great thing is computations such as these can then be done on it afterwards. Here is just a series of examples of doing exactly the same thing. I have a quantity of 3 feet, adding 2 inches. Returns me with a result of 38 inches. Can then find out whether 3 feet is less than 1 meter, and it turns out it is. And then you can do things such as converting feet into meters. So there's your answer to prove that it is in fact less than 1 meter. You can also simplify units. So for example, joules per second, which turns out to be watts. Normally, Mathematica will do this automatically for you. I'm just doing this by manually to show you exactly what it would be doing. So if you did have a calculation that would result in something of joules divided by seconds, then it would automatically turn that into watts for you. This can then be used on other things such as axes. So as you can see here, I'm able to put a unit directly into a series of axes, into an axis on a graph. Nice and easy. So one of the most powerful features of everything I've shown you so far is the ability to pretty much compute and visualize anything. I am not joking when I mean anything. We can do 2D visualizations and quite a large variety of those. Here is a series of 8 examples. We can do 3D visualizations. This is going to take a second to load. All of these can actually be, I could sit here and manipulate and rotate them and zoom in and out and have a look at the features in more detail. Fortunately, I'm not going to be able to do this on a webinar. But then we have more specialized data visualizations, including some specialized plots for things such as engineering, social networks, and statistics. One of the things that is very important with the Wolfram language is the consistency of its syntax. It doesn't matter whether you're plotting a curve or doing the integral of that very same equation. The syntax is pretty much exactly the same. I literally copied and pasted this and changed the word plot to integrate. You can then, again, change this into a 3-dimensional thing. Again, then by changing very little, you can then turn that into a manipulate, where you can choose 2D plot or density. Nothing complicated. The intuitive syntax of the entire language makes things such as ordinary differential equation homework really easy to learn. So our syntax can actually be displayed in exactly the same way on this example piece of homework here. So not only can you go from a piece of homework which your lecturer has given you directly to the Wolfram language, you can actually get out your answers very easily and type it in exactly as you see it on the piece of paper. Other pieces of software such as MATLAB unfortunately do not have this functionality. So as you can see here, here's me doing that exact piece of homework in MATLAB, and it does take a lot longer than I intended it to. One thing I'd now like to highlight is the ability to do all of this on a browser. So getting hold of a Mathematica license is preferable because it means that you can use the resources you have available on your local machine. But if that's not necessarily available to you, then we have here a series of abilities for browser-based applications, which allows you, as I said before, to use either tablets or mobile phones. We even have a Wolfram Cloud app itself, which is optimized specifically for iOS and Android. Again, Mathematica Online is free to all users. So just a quick summary of the teaching applications. We've gone through the tools which we have to make programming easier, showing that you can make concepts easy for students, show how you can then create everything dynamically by easily swapping between using the same syntax and just replacing certain components, showing how you can integrate your real-world data with your computations to actually make things applicable to a variety of subject areas, and then just highlighting the fact that you don't necessarily need a desktop version to actually access all this. So now to specifically highlight things for research. here is a series of examples of what Mathematica is actually currently used for. I'm not going to go into these in any detail, but as you can see, there is a large variety of actual real-world application use for Mathematica at the moment. So to make research easier, there is a series of features. One of the things that we're most proud of is our parallel computation and GPU support. So I don't know about you guys, having to do things sequentially means that it can take quite a long time. In this case, parallelizing such a thing as a sum can actually speed things up quite quickly. In this case, I'm not going to be able to do this for you now because it does actually take some time, and I don't have enough time today. But you can run these on your local computer. Try doing them normally first and timing them, then adding the parallelize, and you'll find that the speed is actually quicker. There is a blog on our website which you can find, which shows how you can quantify the speed with which these things are done. Another thing I've mentioned is GPU support. If you happen to be as lucky as me and have an NVIDIA graphics card within your PC, you'll find that you can use that to increase the speed of some of your computations. So specifically neural networks, linear algebra, some financial computations, quite a lot of image processing, because I'm using a graphics card can be used for image processing a lot faster, who would have guessed, and Fourier transforms. There are other there are a lot of functions which are automatic in their use of your GPU if you have one. There is a series of 3 examples here, which you'll be able to look through in your own time, which highlight its use. Programming Mathematica can be done in a variety of different programming styles. It's incredibly multi-paradigm and has a large and broad range of constructs. If you particularly are focused on the procedural side of programming, then you'll be using something along the lines of these 2 lines of coding here. But if you particularly believe in using entirely functional coding, then you can go along with this line of coding here. The idea is that we're intending to make Mathematica's language, or the Wolfram programming language, as flexible as possible. Here is just a few examples of the functional programming side of things. So just defining a function where we'll take a value of x and square it. By inputting the value 10, you get 100. The value 3.1415. But this can also be then applied to a list of numbers. Or, if you particularly wish to, it can be done to an object. In this case, Mathematica, the Wolfram language isn't able to actually determine what it is, but it still tells you it squared it. You can then define functions that behave differently depending on what the argument is that's actually provided. So in this case, if the number provided is an integer, I want it to perform this function. If the number happens to be a real, then I would like the number of pi to 50 decimal places. If the item happens to be a string, return a red dot. So just to check it, first an integer, hey presto, the sign 1/9. Then a real number, you get pi to 50 decimal places. And then if I give it the word test, I get returned a red dot. I don't know about you guys, but this can actually be incredibly powerful. The Wolfram language syntax allows us to create incredibly powerful programs with very little syntax. Here is a tweetable program, which in fact returns a list of possible Scrabble words from a list of tiles. So here I've given it the letters A, O, E, I, U, Y, and M. And it should return us a list of possible uses of those letters within the game of Scrabble. Quite a powerful thing. As you can see, very little actual coding, but it means that you can create some very powerful small programs. Again, you can also build dynamic graphics with very little syntax. So here is a lovely little animation that is created in what actually should be 1 line of coding, but within the character range of a Twitter. The old character range of a tweet. Again, you can then do things such as shortest path examples, and there's several more examples further down, which you can then go into yourselves, including changing things into parallel. I can't go through all of these today because I'm limited on my time, unfortunately. So another thing within research is the ability to do things at speed. So we have code compilation, which allows things to be, again, as I said, faster. one of the major, as I keep saying, the major benefit is making everything faster. In this case, we're going to compile for a different variety of optional executions. Optimal, there we go, got the right word. So as I mentioned earlier, you can do timing of these functions. So here you can see that the timing for the two different compilation methods is quite significantly different. You can also do compiling specifically for parallelization, which I am hopefully able to show you now. Here we go, give it a second. No. You can also automatically generate code. So for example, I'm going to use change the equation x squared plus sine of x squared, and I'm going to compile it into a series of C code. So I've just stored the compiled version of the equation, load the code generator package, and I've just realized I've missed out something. So I'm going to have to come back to that another time. What you should be able to do is compile this into C code, and then you'll be able to publish that C code in whatever method you choose and use it on your Windows computer in a much faster manner. One of the things we're key to express is that you're not necessarily limited in where you store your data. One of the things that I mentioned here is the integration with R. We also have integration with other database and a variety of other systems, such as Java-based systems, SQL, etc. We also have an IDE available as well, known as Wolfram Workbench, which can be plugged into other development environments such as Eclipse. Mathematica itself has a series of built-in functionality that applies to a large range of areas. So here is just an example of 6. So unlike traditional systems where you would have to go through and vary programs for what you happen to be doing at the time, the idea with Mathematica is you can just open this one program and you have all those tools available in one location. No more worrying about file formats while transferring between programs, or changing to a new program just to do presentation. As you can see today, I'm in fact using Wolfram Mathematica to do this presentation. Here is a series of examples of a variety of uses of the Wolfram language in a series of different domains. Again, I don't necessarily have the time to do today, but as I mentioned, you'll be given this presentation so that you can go through it in your own time. Just a quick nod to Wolfram System Modeler. If you happen to be into modeling and simulating systems, here is a series of example locations where that may be useful. Then we have System Modeler itself, which actually has an access to a large variety of Mathematica standard libraries with which you can drag and drop components to construct systems, or you can create your own. This has a variety of linking capabilities directly into Mathematica, which allows you to do analysis of the systems from within Mathematica. But just to highlight, System Modeler is a separate piece of software as currently. Here is just an example of a few case studies with which Wolfram System Modeler is used. Everything ranging from the Ford F-350 truck to an analysis of a human system. So you're not necessarily limited to mechanical or electrical engineering within System Modeler. There is also the ability to do biological systems as well. However, they are a bit more complicated than I would like to admit. And here is a example of this use within mechanics. Again, we have demonstrations. Here are 2 links with which you can click on, which will show you a demonstration of using Mathematica to control the simulation of either an electric kettle or an excavator. Here are a series of academic initiatives which you guys may or may not be interested in, which will allow you to get hold of Mathematica, Wolfram Alpha Pro, and Mathematica Online quite nice and easily. Again, all the details are at the end of this presentation. So feel free to look through this in your own time. And yeah, any questions?